Everyone, and today we will be seeing one of the problem from Geeks for Geeks. It says rotten oranges. The problem is very simple, and it is a very initial standard problem of you'll know it of a matrix, or I would say graphs in a way. But the problem goes like, given a matrix mat where each cell in the matrix can have either values of 0, 1 and 2, where 0 means an empty cell, 1 means have fresh orange, and 2 means have a rotten orange. And now our task is to determine the minimum time required so that all the oranges become rotten. A rotten orange at index ij can rot, or the fresh oranges at index it is upside down, left and right, so no diagonal things. And if it is impossible, return -1. So now we have certain examples. You can see that these 2's are rotten oranges, so this 2 will directly impact this one and this one, so it will become 2 and 2 here as well, so both of them would rot. And if this one is rotting, then it will also impact this one and it will rot. So at the second time frame, or t is equal to 2, we will have every orange as rot. So that is the reason answer is 2. It might be a case where it's not possible, it's -1, because let's assume that we don't have this layer of 2 over here, and in that case these 1 oranges and this one would be safe, and that's the reason all oranges within the grid or the matrix would never be rotting. So that's a very simple problem to understand, but how would we implement this one? So the implementation is quite tricky. If you can closely look into this, is what I need to do is I need to understand what is the time required, or shall I say I need to understand the step required. So it can be either time required, or I can say the steps required to infect every oranges. So this is the farthermost orange, and to infect this orange I need at most 2 steps. So one step to infect this and another step to infect this. So steps required needs to be calculated. And steps from what? You may ask, step from rotten oranges. So these are our source, because from these rotten oranges only the infection grows. Now, we know our source. We need to just propagate till the oranges, and we cannot propagate into empty cell. We need a medium of fresh oranges. If empty cell, no infection. And in the end we can just do one thing, that we can check if all oranges are rotten, and if yes, then what is time, what is minimum time, or I'll say what is the time, or what is step required. So cool. And if not all oranges are rotten, then I'll just return -1. That is pretty much it. So this is a very classic problem of breadth first search. Obviously I can do it at depth first search as well, but the problem with DFS, and this is the part where interviewer or anyone will be asking you that, hey, what kind of traversal would you use? And it would be sensible to mention depth for DFS as well and BFS, but choose always breadth. I'll tell you why. If you choose depth first approach, then in that case you would first of all go and check all the oranges. So from this 2 you would go to this one, the upper one, the below one, and all of these things. But do you need to? You're just doing the recomputation. Either way, if you can just take one step right, and one step right to this one, within 3 steps you would be done. But now for each 2 you need to take 3 steps. So 3 2's for 3 steps it would take 9 steps. So you don't want to increase the time complexities with this. So the best case solution with depth is BFS, and I'll just do if it is null or a dot length is 0, then just return -1, and these are just validation cases. I know this will not be the case, but this is good to mention. Now what does our algorithm says? So we want rotten oranges as a source, so let us give it. We will have a source which would be a queue of integer, which is source, which would be a new linked list. And what this integer is, ideally if I was in an interview, I would take this not an integer, but I would take it as a class. But for the simplicity's sake, now this integer is nothing but for x, y and the distance. Distance means nothing but a step what is required to achieve till this point. And I will also have integer result, which is initially, I don't know what should I keep initially. Should I keep -1 or what? I'll keep 0. Now I wanted to fill up the source, so I'll just do for int I is equal to 0, I is less than a dot length I plus plus. But wait a second, I wanted to calculate steps as well, so I need steps array as well. So it would be distance array is equal to new int a dot length and a of 0 dot length. Now I wanted to iterate one by one within the matrix. You know how to iterate the matrix is with I help of I and j. 0, j is less than, I don't know, a of I dot length j plus plus, and initially our distance would be filled with -1, because again it's not initialized, so -1 makes sense to keep it as it is. And again, if our matrix meaning a of I j is not equal to 2, that means it is not the source. Nah, I will not use it, because again it's not a source. And but if it is a source, I'll just put it source dot add new int I j and the distance is 0. Why the distance is 0? Again, if you consider distance is 0, that means I myself, this cell itself is a rotten orange. That's the reason it doesn't need to go any further step to reach to the rotten orange, and that's why the distance is 0. When I am out of this, I know that source is filled, and what I'll do over here is I'll take one by one elements from the source. So while source not source dot is empty, I'll do a poll. So int current is equal to source dot poll, and now I'll have x, which is current dot 0. Same goes with y, which is current of 1, and same goes with d, which is distance, current of 2. So now I have removed all of these 3 from this one, and I will check that, hey, if my distance of this x and y, if this is not equal to -1, if it is equal to -1, then I guess it's not initialized and I need to go forward. If it is not equal to -1 and distance of x and y, if it is already smaller than my current distance, I don't want to move, I want it to continue to the next one. So continue to the next one. Cool. And if I'm at the correct point, then I just wanted to improve my distance of x and y is equal to current distance. Cool. I have now chosen the current distance. What I wanted to do, I wanted to go up, down, left and right. I wanted to do this. That means I wanted to have Up means, what should I say up? Is 0? No, it's minus 1, 0, right? Dx dy. So minus 1, 0 means up. Down means 1, 0. Then I wanted to go left. Left means minus 0, minus 1. Then I wanted to go right, means 0 plus 1. Don't worry, these are just dx dy which I would be using for my iteration. So 0 is less than dx dot length I plus plus, or I can say just less than or equal to 4, because I am moving in just 4 directions. 4 directions, yeah. So now how do I need to move? I would first check what is the new x and y and whether it is possible or not. So if my current x plus dx of I, or I would say I'll just take it k, sorry, I'm very bad at choosing the variable names. I would say this I is equal to x plus dx of k, and same goes with y, dy, and this is y, and this is j, sorry. Now if I is less than 0, or I is greater than or equal to a dot length, or in that case I is, so j is less than 0, or j is greater than or equal to a of I dot length. In that case, continue to the next one. And again, as we have seen that we cannot go through an empty cell, so that means if a of ij, if it is equal to 0, then even in that case I don't want to continue next. So yeah, and if I'm getting this distance valid, I wanted to mark it as infected, a of I and j, or I would say x and y is equal to 2, mark infected. Now cool, if my code is at this point, that means I have reached a healthy orange and I wanted to infect it. How do I infect it? So it is already infected, but I wanted to mark it into the source, because this in turn would be infecting other oranges. So add new int, what is my current coordinates of this is I and j, and what are my steps I have taken, d plus 1, because d was the distance required to come to this point, and plus 1 to go to the next orange. Next orange is I and j, and that is where I went ahead. The loop will run for all the 4 coordinates, up, down, left, right, whatever, and it will keep adding. It will first verify and it will keep adding within the source. If I close up the loop, it will go ahead and check the source is empty or not, and it will do again its job. So this was the infection step. Now I wanted to do a verify step. Verify what? First of all, I need to verify whether all the oranges are rotten or not. So I is equal to 0, I is less than a dot length I plus plus. And for j is equal to 0, so is less than a of I dot length j plus plus. And if a of ij is equal to 1, that means, hey my god, this is not rotten. So I wanted to just return minus 1, because this is still a fresh orange. I cannot do anything. Else I have a result variable, right? Where is the result? Okay, I'll take result this side. So result is 0, and what I'll do here is mat.max result and this step. How can I get the step? Is by distance matrix which we have created. so distance ij, and that's how we take it. Return result and we are done. Distance array is a quick check whether we have a proper distance d, store the proper distance d for xy coordinate. So we don't want it to look up back. Let's compile this one. Oopsies. Array store exception. What is this exception? First time I'm seeing it. So it's not this, it's bits of I. So yeah, it has ran for one sample test case. Let's submit it for rest of the test cases as well. And I think it passed the rest of all the solutions. This was a classic problem. Having time complexity of this, which we have already used, and it is a famous problem for most of these companies, and which carries the data structure graph and matrix problem. Mostly the problem, when you see such kind of problem, they are mostly not looking for the solution because anyone can code it. They are mostly looking for the understanding whether, hey, you can justify why you are using BFS or not. You can do it with DFS as well, and hey, that would be a good exercise for you to do it in the depth first search. And tell me, how does that work and how does this work? Until that, click the video on your right for more such data structure algorithm related content, and I will see you in the next one.